Okay, so on the next one, it wants tangent of theta. So if we're thinking about SOHCAHTOA, tangent is the TOA, we need opposite over adjacent. So when we're looking at this triangle, here's theta down here. I think one of the easiest things to mark is opposite because it's a cross. So if I go across, that 7 is the opposite. Now, is the 25 adjacent or hypotenuse? So these look almost the same length. So this one, the 25 is actually the hypotenuse. And the way that I know that is the adjacent always helps make the right angle. The opposite and adjacent, the two legs, make that right angle in the triangle. So I only need the 7. So if I wanted to, I could go ahead and put 7 down. But I don't know what the adjacent is. So we're going to use the Pythagorean theorem. A squared plus b squared equals c squared. So we have to make sure that our hypotenuse goes over here for c. So I'm going to do that first. That's 25 squared. And then the 7 and the side that's missing, that can be my a and b. So I could have a squared plus 7 squared, or 7 squared plus b squared, however you want to do it. And then it equals 25 squared. So 7 times 7 is 49. 25 times 25 is 625. Okay, so how do I get a squared by itself?
Minus.
I'm going to subtract 49 from both sides. Good job. And I don't have my calculator out, so I'm going to do this really quick. So we get 576. And if we square root that, I'm not entirely sure what that one is, so I'm going to work it really quick. So I'm going to do the square root of 576, which is 24. It's not one I had memorized, although it looked familiar. Okay, so that's my adjacent side. So this side is now 24, and I can put that on here. Will this reduce 7 and 24? No, because 7 times 2 is 14, times 3 is 21, times 4 is 28. It's too big. It's not going to go in, so we can just leave it as 7 over 24. Okay, so let's go to the next one. Here's theta. Let's mark our sides. So what sides can we mark? I'm going to get my markers ready.
Okay.
Which side is the hypotenuse? Hypotenuse is the longest side. It's across from the right angle.
The diagonal one.
Yeah, the blank one that's kind of looks diagonal. Okay, so from theta, which side is opposite theta? So opposite means we're going to go
Opposite side.
across. So the opposite side would be 8. And that means that the 15 is the adjacent side. So let's see what we need. So for cosine, we're looking at, so I'm just going to write this out. If I have SOHCAHTOA, this is the part I need for cosine. So adjacent and hypotenuse. So I'm going to do adjacent over hypotenuse. So I know what the adjacent side is. That's 15. I do not know what the hypotenuse is. So we're going to set up the Pythagorean theorem to find that missing side, which we can always do for right triangles. Now we're lucky because the 8 and the 15 are the two legs. That's my A and B. The C part is the hypotenuse, so we won't have to do a lot of solving, just a little bit of math. So 8 squared plus 15 squared is C squared. So 8 squared is 8 times 8, that's 64. 15 squared is 15 times 15, which is 225. We're just putting things into the Pythagorean theorem. And these are, you can do the squareds on your calculator if you don't remember what they are. There's also a poster on the back wall of my classroom. And so if I add those together, I'm going to get 289 equals C squared. What's the last step to get rid of the squared? Square root. Get that vocabulary out. We're going to square root. So if I square root that, that one is 17. So that means that my hypotenuse over here is 17. So I'm going to have 15 over 17. 17 is prime, so I know 15 is not going to reduce with that. But if you could reduce, we want to reduce all of our fractions. Okay, I'm going to stop there for today.